Hi, good morning everyone. Today we are going to discuss about the master information block in 5G. So, which plays the important role while DL synchronization. Okay. So whenever the node restart or whenever the node comes up, so it will transmit the master information block or it will broadcast the information block. So the wherever UV is there, it will read this information and it will synchronize with the network in a DL direction. Okay. So what is the purpose of this MIB? So this MIB contains the information regarding the system prime number and cell related information and the network resources available in the network and the frequencies and the system parameters. Okay, so it will help the UV to access in the initial stage. Okay, so what are the MIB contents or what MIB contains are structure and content of the MIB. So it contains the system information, includes the basic network parameters such as the PCI physical cell ID and the system frame number and the DMRS type A position and the cell barred or not. And these are the major components of the MIB. Okay. As I told, this system information in the MIB is cell identity, so which is derived from the PSS and SSS. Okay, and the physical cell ID and the system frame number. So this information will broadcast based on the periodicity. So uh, in the every frame, it will periodically transmitted towards the UV side. Okay. So the MIB will transmit it in the dedicated physical control channels, specifically in a PBCH only. So it will transmit the MIB to make sure that all UVs can access it. Okay. So what will happen? Some MIB decoding and processing by the UV. So when the MIB will received by the UV through the antennas, it will decode the MIB. Okay, for that it will use some specific algorithms and protocols. So then it will extract the information in the MIB and it will synchronize with the network. So what are the benefits of MIB? Okay, it helps the UV to synchronize, network synchronize in the DL direction, and it will so helps the interface management to avoid the different cells. So based on the PCI, okay, and it will tell the UVs for the resource allocation information. Okay, this is the MIB structure in 5G. So these are the parameters available in the master information block. So first one comes the system frame number. Okay, so it indicates the system frame number for a time synchronization. So usually it is a 10-bit counter, means 0 to 1023. Okay, the 0 means it indicates the first frame. Okay, so it will help the UV to synchronize with the timing synchronization. Okay, then subcarrier spacing common. So it will tells the UV that what SES it is using. 15 or 60 means SES 15 it will use. SES 30 or 120 means SES 30 it will use. Okay. So SES means subcarrier spacing. So this is the space between subcarriers. So many carriers will be there in the network. Okay. So it will tell the UV that there is a spacing between the two carriers. Okay. That is the SES. Then the SSB subcarrier offset means it defines the offset for the SSB subcarrier. So which will help the UV to identify the where the SSB is placed in the frame. Okay. For example, if the SSB subcarrier offset is 10, so it indicates that the SSB placed at the 10th carrier. Then comes the DMRS type A position. The position of the DMRS in a type A. Okay, position 2 or position 3. Position 2 means so the DMRS will comes on the second symbol in the frame or in the third symbol. Okay, then comes the PDCCH config SIB1. So this is the control information for the SIB1. It will tells the UV to where the control information is there. Okay, and the cell barred. Cell barred indicates if the cell is barred or not. If the cell is barred, so UV can't access it. UV can't attach to the cell. If it is not barred, then UV can access the network. Then comes the intra-frequency reselections. It defines whether intra-frequency reselection is allowed or not allowed. so the UV is in the network, so it can move to the other cell with the same frequency.